A pleasant greetings to all. In this video, I am going to explain the realization of flip-flop. What is realization? The realization of flip-flop means conversion of one flip-flop into another flip-flop with some additional gates. This is done by the use of characteristics table and excitation table of the flip-flop. Next, the procedure for flip-flops realization is as follows. Step number 1. Write the characters table of the required flip-flop. Step number 2. Using the excitation table, the flip-flop inputs are filled. Step number 3. Determine the expression for the given flip-flop inputs by using K-map simplification. Step number 4. Draw the flip-flops conversion logic diagram to obtain the required flip-flop. Flip-flops by the expression obtained from step number 3. Here I am going to explain how the SR flip-flop is converted into D flip-flop. In a SR flip-flop, I am going to take the excitation table. And for a D flip-flop, I am going to use the characteristic table of truth table. So first of all, I am going to write the truth table of the D flip-flop. Input, present state and next state. Already I have explained in the previous videos, when the input D is equal to 0, irrespective of the present state, the next state always 0. This is the reset condition of this flip-flop. When input equal to 1, irrespective of the present state, next state always equal to 1. This is the set condition of the flip-flop. And next I am going to explain how the SR flip-flop is converted into D flip-flop. So first, what are the values? I have to put it here. Input, present state, next state, flip-flop input. First of all, I am going to fill the characteristic table or truth table of the D flip-flop here. D, Qn, Qn plus 1. I have to copy down these values here. Afterwards, I am going to explain how to find out the flip-flop inputs. So this is obtained from the excitation table of the SR flip-flop. How we can remember easily. Here, Qn equal to 0 and Qn plus 1 equal to 0. So S is equal to 0 and R is equal to X. Here both are equal to 1. So put X first and 0 next. Next 1, 0. I have to write in a reverse order. Reverse order means 0, 1. 0, 1. Write in a reverse order 1, 0. In this way, I have to fill the excitation table for the SR flip-flop. Next, after finishing this, I am going to explain how to draw the K-map for S and K-map for R from this table. Okay, see here, take D and Qn and find out S. D is equal to 0 and Q is equal to 0, S is equal to 0. D is equal to 0 and Qn is equal to 1, S is equal to again 0. D is equal to 1, Qn equal to 0, S is equal to 1. And D is equal to 1, Qn equal to 1, S is equal to X. And see here, one value is there and next X. So I have to combine both, then only we get the simplified expression. So S is equal to D. Here D, there is no common term here. So S is equal to D. This is the K-map for S. In the similar manner, K-map for R is equal to, have to put the value like S and find out R. R is equal to D bar. There is no common term. So this is the K-map for R. Next I have to draw the symbol. In the symbol put S, R, Q, Q bar. What is the value of S? S is equal to D. And what is the value of R? D bar. How we get D bar? We have to pass the D through an inverter, we get D bar. Okay. So the inverter you have to draw, we get D bar equal to R. So this is the SR as D flip-flop realization. We get the D flip-flop that is obtained from the SR flip-flop. Next, I am going to explain how the SR flip-flop is converted into JK flip-flop. For this, SR flip-flop I am using the excitation table, and JK flip-flop I am using the truth table or characteristic table. So first of all, I am going to explain the truth table for JK flip-flop. Let's see here, J is equal to 0, K is equal to 0, and present state is equal to 0, next state equal to 0. J is equal to 0 and K is equal to 0, present state equal to 1, next state is 1. There is no change in the present state. When J is equal to 0 and K is equal to 1, irrespective of the present state, the next state is always 0. This is the reset condition. When J is equal to 1 and K is equal to 0, irrespective of the present state, the next state is always equal to 1, that is still set of the flip-flop. When J is equal to 1 and K is equal to 1, the present state is 0, it is toggled, that is the complement of the present state, that is equal to 1. If the present state is 1, the next state equal to 0. Okay, next what I have to do, the same input, present state and next state I have to copy down in this table. So this is the characteristic of truth table of the JK flip-flop. After finishing this, what I have to do, I am going to fill the SR flip-flop value. Already in the previous case, I explained how to remember SR flip-flop value in an easy way. Okay, when 0 and 0, put S is equal to 0, R is equal to X. 1 and 1, put S is equal to X and R is equal to 0. 0 and 0, put S is equal to 0, R is equal to X. 1 and 0, inverse the value, 0, 1. 1, 0, inverse the order. 0, 1, 1, 0. 1, 1, X, 0. 0, 1, 1, 0. 1, 0, 0, 1. In this way, we have to complete the excitation table for the SR flip-flop. It's an easy way to remember the excitation values. And next, I am going to find out the K map for S and K map for R here. So use J here and K and QN. J in the vertical side and K in the QN in the horizontal side of the K map. 3 variable we have used here. So 2 power 3, 8 cell coordinate map is used. J is equal to 0, K is equal to 0, 0. What about the value of S? S is equal to 0. And J is equal to 0, K is equal to 0, 1, S is equal to X. 0, 0, 1, 1, S is equal to 0. Then 0, 1, 0, S is equal to 0. In this way, have to finish the remaining also. After finishing this, have to simplify this. Here by grouping the cells. Here 1 and 1, there's a corner cell. The corner cells are grouped together. If we group the corner cell, which one is common? J. J is the common. In the horizontal side, 0 and 0. The second 0 and second 0 is common. 0 is meant for QN bar. So S is equal to J in the QN bar. In the similar manner, we have to find out the K map for R also. So K is equal to J is equal to 0, 0, 0, R value is X. And next fill the 0 value. Next X, then 1. In this way, finish the coordinate map. This is also an 8 cell coordinate map. Here also I am going to simplify this by grouping the neighboring cells together. 2 ones are there. I am going to group the cells together. Here there is no common term, and here we are having K into Qn. 1, 1, 1 A. 1 is corresponding to the value K. Another one is Qn. K into Qn. So R is equal to K into Qn. Next I am going to draw the realization of the JK flip-flop from SR flip-flop. I have to draw the SR flip-flop here. So yes, what is the value of S? S is equal to J into Qn bar. This is Qn bar, no? This is connected here. We get J into Qn bar. And next K into this one is Qn. So K Qn. This is all. In this way, we get a JK flip-flop from SR flip-flop. Thank you. Have a nice day.